This is Equilibrium from 2007, parts D and E. To do this problem, we're going to need to use the amount of moles of HF and OH minus that we calculated in part C. So 0.01 for HF and 0.006 for OH minus. We figured that the hydroxide was limiting reactant, so that is the change, leaving 0 hydroxides left over and 0.004 hydrofluoric acids left over. On the other side of the equation, we're going to be adding an equal number of moles of the fluoride ion, which is our new interesting question for part D. Calculate the molar concentration of fluoride. Now that we know the number of moles, we can divide by the total volume. So 0.006 moles of F minus divided by the total amount, which was 40 milliliters, but since we're doing molarity, we're going to make that 0.040 liters. This will give us 0.15 molar fluoride ion. Go ahead and box that answer, and that's totally the end of part D. Part E is asking us to calculate the pH of the solution. Whenever a question directly asks for pH instead of asking for the hydrogen ion concentration first, that's really what you need to do. So for part E, we need to find out what our hydronium concentration is. We want this so that we can plug it into the pH formula. pH is equal to the negative log of the hydrogen concentration. I'm going to use my equilibrium expression from part A. Hydronium concentration times fluoride concentration over the acid. And this is going to be equal to the given K value, 7.2 times 10 to the negative 4. To figure out what I want to plug in for these values, I need to make a mini ice table just to organize my thoughts. So here we go. Remembering that this is for the dissociation of the hydrofluoric acid. We're starting with a concentration value. Oh my, we only have moles. If we have 0.004 moles of HF and it's inside of 0.04 liters, that means we have a 0.10 concentration of the HF at the beginning of our dissociation. This happens immediately after titration, so I can start with the stuff that I had at the end of the titration. Then we're going to have 0 hydrogens at the beginning and 0.15 molar fluoride from our previous calculation. We're going to shift to the right. Now, how do I know this? I know this because there's a 0 under the hydrogen, and since there's nothing there, according to Le Chatelier's principle, we're going to shift to the right to compensate for that 0. That X amount is going to be the only important number in this entire thing. It's going to be tiny because of my K value, which is 7.2 times 10 to the negative 4. but it will create some amount of acidity. Now, looking at my K value, I realize that my minus X and my plus X are probably going to be really, really small numbers. In fact, they're probably going to obey the 5% rule, which means I get to ignore them. Now, I can't ignore this X because that's our goal. So here's what we're going to plug into our equation. We're going to plug in X times 1.5, which is the fluoride, forgetting about the plus X. Then we're going to divide by 0.10. Now all I have to do is solve for X. And X is going to equal about 4.8 times 10 to the negative 4. Now I have to take that number and plug it into my log, and that will give me a pH of about 3.32. Then you would box that answer. Don't forget to include 2 sig figs after the decimal point when you're doing logs. And that's the end of the 2007 equilibrium problem.